Hello, my name is DJ Lewis and this is Lab 3, Black Hole Orbit. The purpose of this lab was to find the mass of a black hole using position versus time data regarding the orbit of a star around a black hole. The final mass of the black hole was found to be 3.38 times 10 to the 31st kilograms. The main physics principle used was Newton's second law, which can be written in various forms. For instance, Vf equals Vi plus F net over m times delta t. F net equals delta p over delta t, which equals the change in momentum over the change in time. dp dt equals the summation of its perpendicular and parallel components, which we will calculate later. After downloading the CSV file containing the position data of the star's motion, VPython was used to model the orbit of the star around a black hole. This was done by finding the change in velocities over time from the position and time data, then using that to compute the change in momentum dp dt. Next, dp dt was broken down into its parallel and perpendicular components to find F net parallel and F net perpendicular. After F net was found, Newton's universal law of gravitation was used to solve the mass of the black hole. This is because gravity was assumed to be the only force acting on the star from the black hole. Since F net is the sum of all forces acting on the system, in this case the star, we can conclude that F net equals F of g. This procedure was translated to VPython code. The initial conditions, including the star's mass and the black hole's initial position, was given to us. In addition, the time interval between observations, delta t, was given as 1 Earth day or 86,400 seconds. This was placed in the code as well. The velocities, initial and final, were defined under a while loop to find the initial and final momentums. Delta v and delta p were also placed in the code to use later. The next block of code calculates F net perpendicular and F net parallel with the equations discussed earlier. As you can see here, dp dt is the change in momentum over the change in time. F net is equal to dp over dt. Since F net can be split into its parallel and perpendicular components, so can dp dt. Recall that dp dt parallel equals the magnitude of momentum times dp hat over dt, and recall that dp dt equals the summation of its parallel and perpendicular components. This code solves for dp dt parallel first and finds dp dt perpendicular by subtracting dp dt parallel from dp dt. The original gravitation force equation, F of g equals to the gravitational constant times m1 times m2 over r squared, was manipulated to find the mass of the black hole. We were instructed to print the mass of the black hole after the code was run. Running the code produced this model here. The model consists of the yellow arrow F net and the blue arrow F net perpendicular and the black arrow F net parallel. The change in size of the arrows over time depicts the change in magnitude of the F net and its components as the star orbits the black hole, which is depicted by this black sphere. Now, to answer the what does it mean question, F net is the force causing the motion and can't be measured directly because it is the summation of all the forces acting on the star. Though F net is equal to dp dt, dp dt is the change in momentum over time and can be measured directly with the change in velocities over time. Therefore, dp dt and its components can be found experimentally, while F net and its components can only be found theoretically. Now, regarding the what if question, if the motion data is the same, then all the calculations done in VPython will be the same as well, resulting in the same F net. Since the force of gravity equation will have the same terms, the mass of the black hole will also be the same. Thank you for your time. Again, my name is DJ Lewis.